Hey, Kenny, you got a second?
Of course, John. What do you need?
I was hoping I could pick your brain about something.
Okay.
So a scientist reached out to me. They're doing their analysis. They were switched out a column, put on a new one, and they lost some of their analyte. Like they're not seeing what they had seen, prior to switching out this new column. You ever hear of something like this?
I have, yeah. It's actually happened to me a couple times.
What do you think's going on?
Does it look something like this, where on the left-hand side you're seeing the peaks you're supposed to be seeing, injection 1, 2, and 3, but then he switched out the column and saw no signal at all?
Yeah, that's exactly it. Like, where did that peak go? Like, what happened?
I mean, it could be a lot of things. It could be non-specific adsorption. It could be some kind of metal interaction, which has been more publicized lately, especially in a lot of peer-reviewed papers. So it could be one of those two things.
Well, I know certain analyte classes can have this type of chelation or non-specific absorption to metal ions within the flow path. Things like phosphorylated, carboxylated. Those analytes really come to mind when I think about, sticking or, again, absorbing to those metals within the flow. Have you heard of that?
Yeah, so you're exactly right. These phosphorylated or metal chelating groups, what can happen is they'll react ionically with the metal ions, whether it be the iron or the titanium ions in the hardware. And this can happen both on the LC column itself, as well as the actual LC system hardware, things like the needle and the flow path.
Yeah, exactly. And I know there's some kind of workarounds for that too that people will try. Things like putting in additives into the mobile phase, or maybe using some kind of treated column, to prevent that.
Yeah, so the most popular ones are things like PeakLine steel columns and madronic acid. But other people have been using things like citric acid and phosphoric acid in their mobile phase as well.
Yeah, I'm sure for things like, additives, you got to watch out about your MS if you're doing MS work, specifically when it comes to signal suppression or signal enhancement. Anytime you put anything in there, you don't know what you're going to get.
Exactly, because the whole point of using these additives is to mitigate ionic interactions. So they kind of act like ion pairing agents, which can be really bad for your mass spectrometer. You just see less signal because what would be ionized normally now has this citric acid or madronic acid interfering with it. So you can get some very weird effects.
And I'm sure PEEK or polyether ether ketone has its drawbacks too.
It does. One of the scientists here at Waters, Maureen DeLofi, she recently did some work where she looked at different PeakLine columns from a couple of different vendors. And she actually wrote an application note about this as well. And she found that not only are they irreproducible in terms of performance, but over time, chromatographically, you start to see some variability in things like retention time and peak area just from that lack of performance of the actual column.
So Kenny, are there any other technologies that can mitigate these challenges?
Yeah, so we have what's called MaxPeak Premier HPS technology, which is a relatively new technology that Waters came up with. It's applied to both our LC columns as well as some of our LC systems. And what we do is we take the hardware and we add here a hydrophobic layer on top of it. Now, what this does is it mitigates those ionic interactions between the analyte and the metal of the hardware. And it makes a really reproducible and reliable column as well as the systems.
Oh, that's great. I would envision getting expected chromatographic performance right out of the box.
Exactly.
How hard is it to use a MaxPeak high performance surface column?
It is just as easy as changing out a column. When you walked in, I was putting one on my system.
Awesome.
It's just that easy to install these columns.
Oh, that's great.
And use this technology.
And are there any other references we can direct scientists to learn more about this?
Yeah, so there are a couple of peer-reviewed papers that have been written by Waters scientists. One was published in Analytical Chemistry.
Oh, cool.
And one was published in LCGC. And those are great references. And then we also have a lot of Waters application notes on the Waters website.
Fantastic. Well, great. Well, thanks a lot. I'm glad I took up, 5 to 7 minutes of your time here. I'll let you get back to it, Kenny, but
Hey.
thanks.
No problem, JT, anytime.